morning, everyone, and welcome to our 13th AATF Technology Thursday webinar. Today's presentation will again be hosted by Siemens as their second in their two-part series of webinars this week. Our webinar this morning is Load Feeder Configurator Plus, IEC, Electrical Engineering Starts with Intelligent Engineering. Switching and protecting motors is not only selecting control products, it's designing a union of components, cables, and calculations, and on top of that, conform standards and regulations. What if you can design your load feeders for direct online motors within a few clicks and additionally get all the important information like cable cross sections and short circuit calculations? The Siemens new Load Feeder Configurator Plus IEC can do all of this for you. Watch as they demonstrate just how fast and easy it is. Our presenter this morning again is Wolfgang Christ, and he has started his electrical engineering career with a professional training job in Germany. He joined Siemens AG after completing his master's degree in electrical engineering with a focus on electrical power in the early 90s. Siemens provided Wolfgang with many global opportunities as a project and sales engineer, promoter, and specialist consultant. This international experience and educational development as a product manager, business development manager, and international business liaison officer focused on a medium and low voltage systems for energy, machinery, and process technology. It was this international experience that led to his specialist role in international IEC relevant application consulting in electrical machinery and power distribution. Please, excuse me. Please feel free to use the question and answer facility at the bottom of your screen throughout the presentation, and these questions will be addressed by Wolfgang himself at the end of the presentation. Without further delay, let me hand over to Wolfgang to take us through the presentation. Over to you.
A warm welcome to all joining participants of the African Automation Technology Webinar, and especially to my today's second session, addressing intelligent products and engineering tools for the electrical machinery equipment. Within today's session for efficient control panel design, would I like to give ideas on time and wiring saving communication capable control circuit devices besides efficient load feeder configuration. I hope to introduce you interesting levers with examples for intelligent control panel engineering to ensure safe and reliable operation of your equipment. Many thanks to the organizing team for inviting me a second time as presenter for the Africa Automation Technology Webinar. It's really a great honor to present this topic today. My name is Wolfgang Christ, and I'm Technical Application Consultant within Siemens AG in Germany. I have been with Siemens for more than 25 years and working in different application fields for medium voltage and low voltage power distribution systems and electrical machinery control in various parts of the IEC-dominated industrial markets around the globe. Besides me, there's Mr. Kruben Benny, Vice President, Siemens Low Voltage Switchgear and Electrical Products. And it's an honor and pleasure for me to be your speaker for today. And a special thanks for attending today's online session again. And I hope you enjoy it and get the most out of it. The practical application examples I used in this presentation do not claim to be complete in regards to their configurations and applications. The application of the standards is based on the interpretation of Siemens AG. Siemens AG assumes no liability or correctness of their interpretation. Please ensure your responsibility for the safety and proper installation of the products And please take note that Siemens has the right to make changes in this presentation at any time without prior notice. Many thanks for joining this second session talking about electrical control panel engineering starts with intelligent and the examples for control circuit besides load feeder configuration and tools and support for efficient engineering. Let me go for a quick summary of the first session. The best way to a new control panel includes fast, simple, efficient, time and space-saving products. Also, engineering applications. So improve today's solutions for tomorrow's control panels optimized with standard products. That was part of my first session as presented on 29th of September. Now, let's go for easy-to-use solutions for your next project. Easy-to-use software tools and products free of charge for your everyday's work provided by Siemens. We can help you to design your control panel even more efficiently. There are numerous challenges in respect to the control panel engineering. As you see from this poor engineering guy here with his headache, the design phase already sets one of the first milestones over the entire engineering chain and will impact the complete engineering process up to the technical documentation. So the way how to perform the electrical configuration will impact the entire engineering chain. The electrical engineering challenges such as short circuit, temperature, line dimensioning, device selection or control are only some examples the electrical engineer needs to solve towards a reliable and high quality electrical machinery equipment. Unfortunately, will this session not allow to touch every example shown here in the slide. The time will only allow to highlight our focus on control and configuring of load feeders within the remaining time of this session. So let's have a look into control circuits. Push buttons and indicator lights, small devices with a huge impact. What we mean by these items is that push buttons and indicator lights are the human-machine interface. Unlike human-machine interface touchscreens, push buttons and indicator lights provide tactile feedback. If necessary, push buttons and indicator lights can also be combined with HMI touchscreens. I believe you are familiar with push buttons and indicating lights already. Nevertheless, please allow me to go into the example of the necessity of these products and how the fundamental function of push buttons, emergency stop and indicating lights will get an important aspect within intelligent electrical control panel engineering. Please have a look on this picture from a control desk, as this will be used for machine control application. As you see a big number of actuators and indicating lights, the machine operator uses this as interface to control the machine. With open cover, the electrical control was executed by conventional control wiring from the user interface to the PLC system. The Siemens product portfolio can perfectly serve this application. The savings Siemens can offer can be used to reduce costs during the engineering, manufacturing and assembly process. Let's have a look first on a video explaining how easy the Serious Act portfolio can be assembled and adopted to this conventional hardwired engineering example, and after the video to look into what further developments being possible. Great show, isn't it? Let's have a look into a different application example. Imagine you have a machine, as this shown here on the slide, with manual control, the control unit with controller, the display, operator control, display elements, and in addition, an emergency stop operation. Once we open the control box here, you see the visible conventional wiring. So based on the second application example, let's see in the next video how simple this application can be benefit from time, space and material saving using Serious Act devices with Profinet in combination with Siemens PLC system. So connect the Simatic with Serious Act via Profinet and how it works. This we will see now in a video. As you saw, two different applications with Serious Act. One in conventional way of wiring, the other one how to use Serious Act with Profinet and combine it easily with your PLC system. So direct communication with the controller. Let's have a look on the simplified circuit. The saving potential or saving benefits are not only limited to installation time and wiring. The saving benefits include high cost saving potentials. You see the difference on the left side compared to the right side. That's space saving advantages and wiring advantages. You only need the controller and the Profinet cable here on the right side. In addition, does the installation with Serious Act and Simatic allow an integration into the tier portal we have seen in the video. And this enables easy commissioning and maintenance advantages, further to the already mentioned saving potential. Let's have a quick look now into the savings by figures. You see on a picture on the left the classic wiring design and the Profinet wiring design with open door. Here you see the design with closed door, including 12 push-button devices, one emergency stop switch, and one potentiometer. So saving in mounting time versus classic installation was 60% with this small application. This 60% saving in mounting time. Well, it depends, of course, on your hourly base, how many dollars you're going to save, but trust me, if you look into the amount of control panels you're going to do by year, it's a reasonable amount of money. Savings and advantages. So let's summarize them. We have on one hand a reduced enclosure footprint because we do not need the wiring and we have saving potential here in a controller. The devices can be easier embedded in the existing workstations. Reduced number of parts, less connections, and easier field modification and maintenance will result out of the Profibus connection. Reduced labor and engineering time. Second power supply analog module is not necessary. A lot of additional saving potentials just by looking into indicating light and push buttons from Siemens. Take the option to use Serious Act. Let's go now into the load feeder configuration, including the conductor dimensioning inside the cabinet and of course outside the cabinet. Ensure reliable supply and protection for your motor load. So let's go into a dimensioning example. Here's an example for the machine with a control panel and 3 motor loads, all connected to 400 volt systems. So the machine control panel itself is connected to a low voltage main distribution board, and those short circuit current ratings of the electrical equipment must be determined. This can be done by means of design rules, calculation or tests, and this affects not only the main distribution board, this also affects the in-feed point of the control panel, and this affects also the motor load. So once you have a specific power supply, here in this example shown with a 2000 kVA power transformers, you can go for the calculation of the maximum and minimum short circuit currents. For this example, it appears here at the main distribution board with a distance of 10 meters to the power transformer to a maximum of 51.45 kiloamps. And it reduces towards the connection point at the motor control here to 14.25 kiloamps here at the control panel. It further reduces here towards the motor load. Target is now to do the right dimensioning and engineering for the control panel devices and for the load feeders to withstand the short circuit current and to ensure reliable operation during load currents. Electrical equipment must be protected against harmful effects in accordance with the European or International Standard 60204-1. Overcurrent protection in a machine circuit shall be provided if one or both of the following criteria could apply. So the current can be more than the rated value of the component, or the current can be more than the current carrying capacity of the conductors. Current or short circuit current is, besides harmful temperature, one of the most important aspects of risk in electrical equipment. Overcurrent protection includes the short circuit protection of the equipment. As a result, all electrical components used with the electrical system need to be considered on their current carrying capacity. This is independent from the component itself or the electrical connection by conductor or cable. Let's have a look now into the motor starter loads, specifically into the device selection. When overcurrent protective devices are selected, the rated short circuit breaking capacity shall be more equal the prospective fault current at the point of the installation. The selected current setting shall be as low as possible, but adequate for the anticipated overcurrents. So it's ensured that the motor starting goes smooth without any interruptions. The protection of the control devices against damage by overcurrents, for example welding of the control device contacts, must be guaranteed. And the current carrying capacity of the protected conductors shall also be taken into consideration. The current carrying capacity of cables or conductors is depending on several factors. It's the interlating material of the conductor itself. It's the number of conductors or cable in a line. It's the design itself, but also the installation method, as installation method inside of the cabinet or outside of the cabinet can be completely different. Grouping, how the arrangement of the different load feeders and conductors is done in the application. But also the ambient temperature takes an important role in dimensioning and designing the right protection devices, switching devices, and conductor material. For this example, we used an 11 kilowatt drive operated under 400 volts. So nominal current for this one is 22 amps. Every live conductor requires overcurrent protection that interrupts the short circuit current before the conductor has reached its maximum permissible temperature. So the conductor material needs to be designed as per load current, but also overcurrent protection does not exceed its permissible current. So for this example, we identified the right motor circuit breaker as the protection device and the conductor, and the task is to identify the minimum required cross-section of the conductor material in line with those factors shown here in the middle of the slide. Dimensioning of load feeders goes very easy if you have the right knowledge or if you have the right tools. Load feeder dimensioning requires precise information and knowledge. So you need to have the requirements for general operating conditions such as voltage rating, frequency, current ratings, type of the distribution system, TNS, TNC network, IT network, besides application-specific requirements including load characteristics. Tripping classes shall also be considered during the engineering phase. Once those general operating conditions are available, you can go for the right load feeder dimensioning, whether you talk about a direct load, a reverse starter load, or star delta starter load. And those is being usually equipped inside of the control cabinet and is going to operate the loads during specific environmental conditions, which also rely on the temperature inside of the machinery, or temperature inside of the cabinet could be much different, and the loads itself also be operated in different distances connected to my control panel. Let's go into a calculation example how intelligent software tools supporting your engineering for the load feeders. From my personal point of view, today's best tool serving the needs for load feeder configuration is inside the Siemens tier selection tool. The Load Feeder Configurator Plus for IC version is integrated within the offline tier selection tool and being available free of charge can be downloaded from www.siemens.com/control-panel-and-tools. And let me open those tools to look into this example. I installed the tool on my desktop computer and going to open it. Takes a little bit time. I'm going to add a new project. Personally, I love to go into the project view. Select a new device from Industrial Controls and go for the Load Feeder Configurator Plus IEC version. I look into the in-feed point. I look at the value settings, voltage range, frequency, maximum short circuit current rating as it's applicable for my application, rated diversity factor for the application. and I go into my circuit. So rename the feeder to my example 11 kilowatts as a direct starter and go to my electric load. Cross-check on the data entered, looking into the value 11 kilowatts, 22 amps, this is the rating nominal current, change to the rating current, cable length of my application, ambient temperature in the plant. So cross-check on the connections, the application direct starter, protection, circuit breaker included, coordination type 1 or 2, control voltage, whether it's DC or AC voltage, I choose 24 volt DC, class, screw or spring terminal connection, temperature in the cabinet itself, number of loads in the circuit, and the installation method. I can go for the calculation, and we see from the calculation point of view that I receive different options on a protection device and contactors, which I can select to my demands now. So I selected the ones I needed. The wiring data is already calculated and visible here in the graphical point. And I can see the overall circuit for those one here in my single line diagram. Accessories as shown here can be added, modified, changed as per your application requested. So printing of the documents, I select what I need and start printing of the documents for my technical documentation. But easy copying of the existing circuits, modifying the existing circuits to the application demand is quite easy. That's intelligent software tools as free of charge provided for Siemens and shown here for the example with a different load feeder for reverse starter, and with the same procedure calculating the protection and the switching devices, the options being shown here and selected, and automatically calculated the right dimensioning of the conductor material as visible shown over here. So get the information printed in the way you want, and there's a huge variety of the documentation needed. The calculation and documentation results of the Load Feeder Configurator Plus includes the technical data and PDF extract of the configurator as we have just seen in my prepared example. It further gets the information about the calculation details, show short circuit calculation, maximum, minimum values can be visible and extracted. Extracted also the overall configuration as single line diagram including technical data and as well as the products combination. Accessory configuration we saw in the video quite easy to get and to modify. This is the way how from our point of view intelligent engineering works for control panels. More information about trends in panel building you will find on our market portal. So go for more information on starting motors, for example. Please feel to refer to our internet page, Trends in Panel Building, which you get from our market portal. At the end of the session, I would like to summarize tools and support for efficient engineering. In addition to the already introduced engineering tools, there's Siemens more intelligent engineering tools for control panel applications. Simaris Design and Simaris Curves is part of the Simaris suite. That's one package ready for download free of charge. Simaris Design and Simaris Curve support device selection for control paneling and selection of the appropriate protection devices. Simaris term can be downloaded as a single package and supports the verification of temperature rise and temperature rise calculation within your control panel. So all software tools save time in the production of documentation for your verification management. And these tools are typical control panel application tools free of charge for your purpose. Additional information, downloads can be done from siemens.com/control panel. Here you find expert interviews, videos, practical tips, white papers, reference manuals, webinars, web-based trainings. And if you're looking for something more or you identified additional questions to be answered, please feel free to use the Get in Touch button. Me and the team, we are happy to support you on these matters. If you find this webinar useful, get more webinars from our registration page under www.siemens.com/control-panel/webinars. Register for the upcoming English webinar series on industrial control panels and feel free to watch the recorded webinar sessions after registrations. Thank you very much for the time sharing and your attention. For more information, visit us at siemens.com control panel or contact your local Siemens partner. Thanks for being here. Hope you enjoyed the session. Have a wonderful day.
Thank you so much, Wolfgang. That was very insightful. We do have a couple of questions that have come through, so we'll go through those questions and Wolfgang will be answering them live. If you haven't had a chance to ask your questions as yet, please ensure that you do that through the question and answer facility that is at the bottom of your screen, and they will be answered live. Okay, so moving over to the questions. The first question, what is the maximum kW rating which we can go up to with the load configuration tool?
Hey, that's a good question. Hope you can hear me. Right now, the configurated, thanks. Right now, the configuration tool supports motor starter application up to 55 kilowatt.
Great, thank you. And then the question that follows on from that is, what happens if we have a higher kW rating?
That's even more interesting. Yeah, right. Well, at the moment, the software tool does not support 55 kilowatt above. That's why the team in South Africa have created a selection tool for higher kilowatt ratings, specific with fault ratings and system voltages for the African market. We indeed are working towards the configuration development further, and with the next release, probably in December, we get the ratings up to 250 kilowatt. So no worries, we have the solution for you.
Great, thank you. And the last question that's come through is, does Siemens have a type tested panel available in South Africa?
Yes, we do have. We have the Sivacon S8 panels, which are fully tested in accordance to IEC 61439. And we have 5 Sivacon partners, to my knowledge, in South Africa to support the market with these panels.
Great. Well, thank you so much, Wolfgang. That was very insightful. Our audience was very engaged as well. If any of the attendees have any further questions, please feel free to contact the AATF team directly or Siemens, and the AATF team will obviously facilitate those questions through to Siemens as well. So that does bring us to a close of our 13th AATF Technology Thursday session. Thank you again, Wolfgang and the Siemens team, for an informative and knowledge-sharing session. Our next Technology Tuesday series does continue next week on the 6th of October at 2 p.m., where we will hear from Turk Banner as they discuss decentralized automation as an effective enabler of Industry 4.0. Stay safe, and we will see you next week. Thank you for attending. Bye-bye.